Have you ever wondered if there's another version of you somewhere else? Not just a little different, but entirely different. Someone who made the choice you didn't. Someone who stayed when you left. Said yes when you said no. Lived the life you often imagine when you're alone with your thoughts. What if this isn't the only universe? Tonight, I want to take you somewhere far beyond the edges of what we know. Not just to the stars, but further to the space between spaces, to the hidden folds of existence where time trembles and reality becomes fluid. It might sound like science fiction, and in many ways it is, but fiction has a funny way of getting close to the truth, doesn't it? Especially when science, too, begins to whisper the same impossible things. The idea of a multiverse, a cosmos not with one universe but many, is no longer just the realm of fantasy. It's creeping into the language of physicists, slipping between the cracks of our deepest theories, and quietly haunting the halls of modern cosmology. But before we go further, let me ask you a quiet question. If there were other universes, how would you know? Would they look like ours? Would they obey the same rules? Would they have people like us wondering the same things? And most of all, would it matter? The journey we're about to take isn't about answers. It's about possibilities. Somewhere out there, or perhaps in here, inside the folds of consciousness, lies a question that no one has answered, but everyone has felt. So close your eyes if you like. Let the hum of the universe settle over you like a blanket. And allow yourself, just for tonight, to imagine that this world is only one page in a book without end. Are you ready? Then let's begin. There was a time, not too long ago really, when the entire universe fit inside a box. Not a literal one, of course, but in the mind of humanity, the cosmos had walls, edges, a ceiling you could not break. It was comforting, in a way, like a room with a roof over your head, even if the stars were painted onto it. Picture this. The year is 150 AD. The Roman Empire stretches across continents. In Alexandria, Egypt, a man named Claudius Ptolemy is looking up at the sky, the same sky we look at now, and trying to make sense of it. But without telescopes, without satellites, all he has is what the naked eye can see, and what the heart dares to believe. And he believes something deeply elegant, that the earth is the center of all things. Above us, the sun rises and sets. The moon dances through its phases. The stars shift ever so slightly, but predictably, across the seasons. It makes sense, doesn't it? To imagine that we are still, and the heavens revolve around us in perfect harmony. Ptolemy takes this idea and gives it form. He imagines a universe built like a celestial machine. The earth at the center, surrounded by a series of giant, invisible spheres. On each sphere rides a planet, the sun, the moon, and the stars, each orbiting in careful loops and curves called epicycles, all turning in unison like gears in a cosmic clock. And this wasn't just a theory. For over 1,400 years, the Ptolemaic system wasn't questioned. It was taught, revered, and protected. It gave us a sense of place in a universe that otherwise might have felt terrifyingly big. The earth was not just central. It was sacred. Everything had a purpose. Everything had a home. At night, under candlelight, medieval monks and scholars would draw charts of the heavens, mapping out how the stars would move when eclipses might come, where Mars would travel across the sky. They were tracing the rhythm of a universe that seemed orderly, contained, and complete. But here's the thing about boxes. Eventually, we grow too large to stay inside them. In time, cracks began to appear. Not literal cracks, but questions, small, quiet doubts that wouldn't go away. Why did planets sometimes move backward in the sky, in a strange loop, before continuing on? Why were the motions so complex and inconsistent, if everything was meant to be perfect? And perhaps deeper than that, what if we weren't the center? What if everything didn't revolve around us after all? These questions were dangerous. They didn't just challenge astronomy, they challenged meaning. If the Earth wasn't central, then maybe humanity wasn't either. And that was a thought most people weren't ready to face. But the sky, ever patient, kept whispering. 1,000 years after Ptolemy, a quiet revolution began. Started not with shouting, but with silence. With stargazers watching the planets for decades. With calculations scribbled in margins. With one man, Copernicus, daring to imagine a universe where the Earth wasn't the center, but instead orbited the sun. That story of Copernicus, Galileo, Kepler is a tale for another part of our journey. But for now, let's linger here a bit longer in this old closed universe. Because it tells us something important. For a long time, humanity believed in a cosmos that was finite, neatly arranged, like a celestial snow globe, shaken gently by divine hands. And even in that small model, we still found wonder. We mapped the skies. We gave names to constellations. We made myths out of Orion and Andromeda. We looked upward and saw more than stars. We saw gods, stories, fate. Even in the limits of the Ptolemaic box, imagination flourished. But imagination, too, wants to stretch. And the universe, it was always bigger than the box we put it in. We now know that the Earth spins, that it orbits the sun, which itself drifts inside the Milky Way, which is just one galaxy among billions. But before we could reach that truth, we had to first unlearn the comfort of centrality. We had to step outside the boundaries we drew for ourselves. Isn't that true of so many things? We build small, safe explanations for the world, not because they're wrong, but because they help us sleep at night. And then, slowly, the truth expands, sometimes gently, sometimes painfully, but always towards something greater. So if tonight we talk of multiverses, of infinite realities, alternate lives, other versions of you, don't forget where we started. In the beginning, we thought there was only one world, one Earth, one sky, one universe, all contained, all explained, all wrapped in the comforting logic of circles and spheres. But then a whisper came. What if it's more? What if it never ends? And that whisper is what led us here. The universe, as we once knew it, had edges. It was closed, ordered, harmonious, with Earth at its quiet center, like the heart of a delicate clock. But all clocks eventually tick toward a moment of change. And that moment, when the center shifted, began not with a bang, but with a whisper. A whisper from a man who lived among cathedrals and shadows. A man who didn't scream his truth, but waited, almost until death, before allowing it to see the light. His name was Nicholas Copernicus. He was a mathematician, priest, a man who watched the stars not for power, but for understanding. And what he saw troubled him, because the heavens, which were supposed to move in perfect circles around us, weren't behaving. The loops of the planets were messy, inconsistent. Mars, in particular, would drift backward in the sky, only to resume its path again, something the old geocentric model could only explain with awkward twists and patches. Copernicus began to wonder, what if we weren't the center at all? What if the sun was? It was a dangerous question, one that went against centuries of tradition, theology, and certainty. But it was a question that, once born, refused to die. He worked in silence for years, building his model carefully. It was elegant. Stripped of the convoluted epicycles and celestial spheres, the solar system centered around the sun finally made sense. The backward motion of planets? Just an illusion caused by Earth's own motion. The complexity of the skies? Just a matter of perspective. In 1543, on his deathbed, Copernicus published his great work, De Revolutionibus Orbium Coelestium, on the revolutions of the celestial spheres. And with that quiet book, the world tilted. But revolutions, the real ones, are never instant. They unfold like dawn. Slow, reluctant, resisted. The sun may rise, but the night doesn't leave all at once. Copernicus had lit the fuse, but it would take decades, even centuries, for the explosion to come. The problem wasn't just astronomy. It was identity. If the Earth moved, if we circled the sun like any other planet, then what did that say about us? Were we not special? Not chosen? Not central? It was a blow not just to science, but to the soul. But truth is patient, and it finds its messengers. One of them was Galileo Galilei, Centuries after Ptolemy, just a few generations after Copernicus, Galileo built a telescope, crude by today's standards, but revolutionary in its time. And through that lens, the heavens opened. He saw craters on the moon, imperfections, where there should have been divine smoothness. He saw moons orbiting Jupiter, little worlds moving around something that wasn't Earth. And he saw Venus go through phases, just like our moon, proof that it circled the sun, not us. Galileo wasn't just observing. He was shattering walls. And for that, he was silenced. In 1633, the church forced him to recant. They told him to say that the earth did not move, that the sun did not stand still, that what he saw was not real. And Galileo, old and weary, obeyed outwardly. But legend says, as he stood up from his confession, he whispered under his breath, "Eperis I move." And yet, it moves. From Copernicus to Galileo, the center was falling away. And in its place, something terrifying bloomed, a vastness. The earth was no longer the still point of all creation. We were not at the center of the turning spheres. We were a planet, orbiting a star, drifting in the dark. But here's the strange thing. In losing the center, we found something deeper. Because the Copernican revolution didn't make us smaller. It made the universe bigger. It invited us to imagine beyond the dome, beyond the ceiling of stars, beyond the tidy box we'd drawn. And this shift, this deep turning, wasn't just scientific. It was spiritual, emotional, existential. For the first time, we weren't just looking at the stars. We were realizing we were among them. We were part of the same fabric, made of the same atoms, moving to the same invisible rhythms. So tonight, if you step outside and look up, let it sink in. That patch of night above you once held an entire universe. Neat, bounded, centered around you. And now it stretches endlessly in all directions. And maybe, just maybe, in every direction there are other worlds, other stars, other minds wondering the same things. It began with one man, alone in a tower, daring to question where center truly lies. And in doing so, he opened the door to infinity. After Copernicus moved the sun to the center, and after Galileo pointed his telescope into the heavens and dared to say, "And yet it moves," something began to shift, not just in our understanding of the stars, but in our understanding of order itself. It was as if the universe had been cracked open, and light was beginning to pour in. But we still didn't quite know what laws governed that light, that motion, that cosmic dance above our heads. That's when a quiet genius named Isaac Newton stepped into the story and rewrote reality. Imagine a young man sitting beneath a tree. The story says an apple falls, a simple moment, barely worth noticing. But in Newton's mind, that falling apple becomes a question that echoes through the heavens. Why does it fall? And stranger still, could that same force that pulls the apple to the ground also keep the moon in orbit? Could gravity be the invisible hand that ties together apples, planets, stars? In Newton's world, the answer was yes. And suddenly, everything snapped into place. What Newton gave us was not just a theory of gravity, but a universe of laws. A place where everything, from the drop of a pebble to the spin of a planet, could be described, predicted, calculated. It was breathtaking. In 1687, he published Philosophiae Naturalis Principia Mathematica, a work that would become one of the most important books in human history. Inside, Newton laid out a vision of the cosmos that was bold and revolutionary. The universe was a machine, a grand, elegant, mechanical system, and it operated with perfect precision.
No chaos, no miracles.
No divine intervention needed, just motion, force, Massachusetts, and time. You could now write equations that described the orbit of planets with exquisite accuracy. You could predict eclipses. You could understand tides. Even the flight of a cannonball followed rules, and those rules worked as well in the heavens as they did on Earth. For the first time, the universe seemed not only knowable, but calculable. If you knew where everything was and how fast it was moving, you could, in theory, predict the future. This was the birth of determinism. The idea that everything was governed by fixed mathematical laws and that nothing happened by chance. The Newtonian universe was beautiful in a way that soothed the mind. It was a cosmos you could trust, a place where every gear turned for a reason, where the stars were just massive bodies obeying gravity, where the Earth spun not by magic, but by momentum. People began to speak of it as a giant clock, wound up at the beginning of time, and now ticking forward with absolute regularity. It was comforting and a little cold, because in this universe, there was no room for spontaneity.
No misteri.
No why, only how. Even the human mind, once thought to be a spark of divine chaos, was now, in theory, just another part of the machine. Brains were physical objects. Thoughts, perhaps, were just chemical reactions. Consciousness, maybe just an illusion produced by the clockwork of the brain. The more we understood the laws, the more predictable we became. And yet, the Newtonian view wasn't meant to rob the universe of wonder. In fact, Newton himself was deeply religious. To him, discovering the laws of nature was a way of glimpsing the mind of God, not replacing it. He didn't believe the universe wasn't sacred. He believed it was so sacred, it obeyed laws so elegant they could be written in the language of mathematics. But over time, others would take Newton's machine and stretch it far beyond what he intended. The 18th and 19th centuries were the age of confidence, the age of science as certainty. Engineers built steam engines and railroads. Astronomers mapped stars with pinpoint accuracy. Physicists studied thermodynamics, electromagnetism, optics, and underneath it all, Newton's laws ticked like clockwork. The world became a puzzle we believed we could solve completely, piece by piece. People began to whisper, if the universe is just matter in motion, what need is there for soul? For mystery? For purpose? We could now explain the rising of the sun, the rhythm of the tides, even the faint wobble of the earth. It all became mechanical, predictable. The universe, once a divine song, became a silent machine. Some found comfort in that. Others felt a quiet grief, as if the stars had been dimmed, not by clouds, but by certainty. But the machine was not perfect, because in the shadows of Newton's great edifice, tiny cracks were beginning to appear. Strange things, quiet things. Light didn't always behave like a wave. Sometimes it acted like a particle. Mercury's orbit was slightly off, and Newton's gravity couldn't quite explain it. And when people tried to measure the speed of light, they found that no matter how fast you moved toward or away from it, it always seemed the same. It was as if the universe, underneath its mechanical surface, was hiding something stranger, something deeper. The gears of Newton's clock were starting to slip, and waiting just beyond the edge of that perfect machine was a young man with wild hair and a soft voice, a man who would take the equations and bend them, who would show us that time could stretch, that space could curve, that gravity was not a force at all, but a ripple in the fabric of existence. Albert Einstein, but that's a story for later. For now, let's sit for a moment in the Newtonian world. A world of order, of precision, of laws that govern all things. It was a necessary step, a vital chapter in our story, because before we could see the universe as strange and wild and unpredictable, we first had to believe we understood it. We had to build the machine before we could hear it hum. By the time Albert Einstein appeared on the stage of history, the world was still ticking by Newton's clock. It was a beautiful machine, well-oiled and predictable. For centuries, it had given us answers. It had guided ships across oceans, charted planets across skies, and powered the birth of the industrial age. But as the 20th century dawned, something about the old machine no longer fit. It wasn't broken, but it was incomplete. Something deeper, stranger, was hiding beneath its gears. And then came Einstein, a quiet dreamer with a mind that seemed to bend light itself. He didn't start as a physicist of fame or fortune. He was a patent clerk in Switzerland, reading other people's inventions by day, but by night, he dreamed. Not of machines, but of motion, of light, of time. He once said, "I thought of that while riding my bicycle." That's the thing about Einstein. He didn't just solve equations, he imagined. He visualized trains, clocks, and beams of light. He asked questions no one thought to ask, like, what would happen if you chased a beam of light? What if time isn't absolute? What if gravity isn't a force, but something deeper? And the answers he found would change everything. In 1905, Einstein introduced the world to his special theory of relativity. It was radical. It said that time and space are not fixed, they depend on your speed. The faster you move, the slower time goes for you, and the very fabric of space itself begins to warp. But that was just the beginning. In 1915, he unveiled something even more astonishing: the general theory of relativity. It began with a simple idea, born not in a lab but in Einstein's own imagination. What would happen if you were falling freely, like in an elevator plummeting through space? Would you feel your weight? He realized something profound. Gravity isn't just a force pulling you down. It's the curvature of space and time itself. Imagine the universe not as empty, but as a fabric, a vast, invisible sheet stretching in every direction. Now place a star on that fabric. It sags beneath the weight, like a bowling ball placed on a trampoline. Place a planet nearby, and it doesn't move in a circle because it's being pulled by some invisible force. It orbits because it's rolling along the curves of that bent fabric. It's simply following the shape of space itself. Gravity, Einstein said, is geometry. Mass tells space how to curve, and curved space tells objects how to move. Let that sink in. This wasn't just a new theory, it was a new universe. Space is no longer flat and still. Time is no longer universal and unchanging. Together, they form a four-dimensional fabric, space-time, that stretches and bends and ripples. And we, our bodies, our planets, even our thoughts, all move across it. This view of the cosmos is almost poetic. It's no longer the hard gears of Newton's machine, but something softer, almost alive. A fabric that responds to the presence of stars, black holes, galaxies, and we can see it. In 1919, during a total solar eclipse, astronomers observed starlight bending around the sun, just as Einstein predicted. Gravity was warping space, bending light, reshaping the path of reality itself. The world was stunned. In a single moment, the universe became stranger and somehow more intimate. Einstein became a global icon not just of science, but of wonder, of imagination, of the idea that reality is deeper and more mysterious than we ever dared believe. And the more we looked, the more evidence we found. Black holes, once just a bizarre consequence of Einstein's math, turned out to be real. These were places where space folds in on itself, where time slows to a crawl, and where gravity becomes so intense, nothing, not even light, can escape. Then came gravitational waves, gentle ripples in space-time itself, like vibrations in a vast, cosmic ocean. We first heard them in 2015, 100 years after Einstein predicted them. It was like the universe had whispered, and after a century of silence, we finally heard it. Two black holes had collided over 1 billion light-years away, and the echo of their embrace traveled across space-time, through stars, through galaxies, until it passed through Earth and through us. We had touched the fabric of the cosmos. In the Einsteinian universe, time is not a river flowing equally for all. It stretches. It warps. Clocks on a mountain tick faster than clocks at sea level. GPS satellites orbiting Earth need constant correction because their time moves differently. Even your own body, every cell, every heartbeat, ticks at a slightly different rate depending on your altitude, your speed, your mass. We are living in relativity. This isn't just math. It's woven into reality. And perhaps the most haunting idea is this: in Einstein's view, time doesn't flow the way we think it does. The past, present, and future may all exist at once, different slices of the same cosmic loaf. What we call now is just our slice, but the whole loaf is there, already shaped. It's unsettling. It's beautiful. It makes you question everything, including free will, destiny, and the nature of memory. And yet, even Einstein's universe has its mysteries. His equations work on the grandest scales: galaxies, stars, black holes. But when we zoom in down to the tiniest particles, to the strange world of atoms and quarks, the rules change. Quantum physics, with all its probabilities and uncertainties, doesn't play well with Einstein's smooth curves. The two frameworks, relativity and quantum mechanics, are both stunningly accurate and stunningly incompatible. It's as if the universe has two rulebooks, one for the very large, one for the very small, and we still don't know how to unite them. Einstein spent the last years of his life trying, but the final equation eluded him. Even today, it eludes us. Still, what Einstein gave us was more than a theory. He gave us a new way of seeing. He showed us that the cosmos is not a machine, but a dance. That time and space are not rigid, but alive. That even the most familiar things, gravity, motion, light, hold deeper secrets, waiting patiently for us to ask the right questions. And perhaps, most of all, he reminded us that imagination is not a luxury. It's the doorway to truth. Because sometimes, the universe changes not with a bang or a flash, but with a quiet thought, what if? For thousands of years, we believed the universe was singular, a closed system, one grand stage where all of existence, stars, galaxies, atoms, life, and time, played out. It was the universe, the only one. And why wouldn't we believe that? After all, it contained everything we could see, feel, and measure, from the glow of distant galaxies to the breath in our lungs. Felt complete. But over time, cracks began to form in that comforting idea. The more we learned about this universe, the less alone it began to feel. The story begins, strangely enough, with a single equation. In the 20th century, physicists wrestled with two competing visions of reality. On one side stood Einstein's elegant general relativity, smooth, vast, continuous. It ruled over planets, stars, and gravity itself. But on the other side was something stranger, weirder, quantum mechanics. It was a realm of probabilities and uncertainty, a place where particles existed in multiple states at once, where the act of observing something seemed to change what it was. And nestled inside this chaotic world was a question no one could answer. What really happens when a quantum particle makes a decision? Let's take a moment to imagine. Picture a tiny particle, let's say an electron, facing a choice: spin up or spin down. In classical thinking, it would simply choose one. Done. But in quantum theory, it doesn't just choose, it exists in both states simultaneously, in a superposition until someone measures it. It's as if the universe keeps all possibilities open until you look. That's the mystery at the heart of Schrödinger's cat, the famous thought experiment where a cat inside a box is both alive and dead at the same time, until you open the lid. Ridiculous? Maybe. But that's what quantum math told us. So the question became, when the universe chooses a result, what happens to the other possibilities? Where do they go? Do they vanish? Or do they continue? In the 1950s, a young physicist named Hugh Everett III proposed something radical. He said, what if they don't vanish at all? What if every time a quantum event occurs, every time a particle chooses between two paths, the universe itself splits? One version of reality continues with outcome A, another continues with outcome B, and so both outcomes exist. Both are real, both unfold in parallel. That was the birth of the many worlds interpretation of quantum mechanics. It was wild, almost science fiction, but it solved the math. And it meant that the universe doesn't just collapse into one history, it branches, over and over and over again. You, right now, are the result of one branch. But in another universe, you didn't click this video. In another, you became a painter, or a physicist, or never existed at all. At first, Everett's idea was ignored, even ridiculed. The thought of an infinite number of parallel realities seemed too extravagant, too unprovable, felt like fantasy. But over the decades, something strange happened. Other areas of physics, completely unrelated, began whispering the same unsettling idea. The cosmos, it seemed, had secrets it wasn't hiding very well. Let's start with inflation. Not economic inflation, cosmic inflation. Back in the 1980s, physicist Alan Guth proposed a theory to explain something puzzling. Why does the universe look so smooth, so uniform on a vast scale? He suggested that right after the Big Bang, the universe underwent a sudden, mind-bending burst of expansion. In less than a trillionth of a second, space itself ballooned, faster than the speed of light, smoothing out all irregularities. That was inflation, and it explained a lot. But inflation had a bizarre consequence. It didn't necessarily stop everywhere at once. In fact, quantum fluctuations could cause inflation to continue eternally, bubbling off new regions of space, endlessly, each becoming its own universe with slightly different properties. This idea is called eternal inflation, and it suggests that what we call the universe is just one bubble in an infinite foaming sea of bubbles. Each bubble a universe, each governed by different physical laws. Some might have no stars, some no gravity, some no atoms. Some might be eerily similar to ours, with a version of you watching this video just with slightly different socks. And then came string theory. In an effort to unify the laws of physics, string theorists proposed that all particles are actually tiny vibrating strings, and that their vibration patterns determine the particles we observe. To make the math work, string theory requires more than 3 dimensions of space. It needs 10 or even 11. Most of these extra dimensions are curled up, hidden from view. But here's the twist. String theory doesn't predict one universe. It predicts a landscape of possible universes, up to 10 to the power of 500 different configurations, each with different laws of physics, different particles, different outcomes. It's not just a multiverse of copies, but a multiverse of fundamentally alien realities. Suddenly, the multiverse was no longer just a quantum quirk or a sci-fi trope. It was showing up in cosmology, in string theory, in equations that describe the very birth of time. And slowly, reluctantly, physicists began to ask, what if this isn't just math? What if it's real? What if our universe isn't the universe, but just one universe among many? Now let's pause here. The idea of a multiverse is seductive, captures the imagination, promises endless worlds, endless yous, endless chances. But it also raises difficult questions. If there are infinite universes, what makes ours special? If every possible version of you exists somewhere, does choice still matter? And most of all, how could we ever prove it? Right now, we can't directly observe other universes. They may lie beyond our cosmic horizon, too far, too fast, too hidden. But indirect clues may exist. Patterns in the cosmic microwave background, strange alignments, anomalies, or perhaps one day, a ripple in space-time that hints at a collision between our universe and another. The multiverse remains a frontier, a hypothesis, a bold whisper from the edges of reason. But in the quiet of night, when the stars stretch across the sky like scattered dreams, it's hard not to wonder, what if this isn't the only sky? What if there are other suns, other moons, other lives? What if, beyond the veil of our reality, there are countless others just waiting to be imagined? Close your eyes for a moment and picture the night sky. Imagine standing beneath it, alone in the quiet, with stars stretching from horizon to horizon, tiny beacons scattered across a cosmic sea. Now, imagine that sea has no shore, that the universe doesn't just go on far but forever. Not metaphorically, not poetically, but literally, endless. This is where the idea of the level 1 multiverse begins. It's not built on wild theories or complex equations. No strange dimensions or quantum splitting. In fact, it's the simplest kind of multiverse there is. All it needs is infinity. Let's start with something we know. Our observable universe, the part we can see, measure, and interact with, is vast. About 93 billion light-years across. But it's not the entire universe. It's just the region where light has had enough time to reach us since the Big Bang. Beyond that, we don't know for sure. But according to most cosmological models, space doesn't just end. There's no edge, no cosmic wall. Space may continue indefinitely, smoothly, uniformly, with more and more galaxies, forever. If that's true, if space is truly infinite, something strange and beautiful happens. In an infinite cosmos, every possible arrangement of matter that can happen must happen. It's not a poetic possibility. It's a statistical necessity. Imagine the universe as a giant cosmic lottery. Every star, every atom, every life is a number drawn from a hat. If the hat is big enough, eventually the same number will come up again, and again, and again. In other words, if the universe is infinite and governed by the same physical laws everywhere, then there are regions unimaginably far away that look exactly like our own, with the same Earth, the same continents, the same people, the same you sitting there right now, watching this video, and somewhere even farther away, there's another you who paused this video 2 seconds earlier. And somewhere else, there's a you who never found it at all. This might sound like fantasy, but it follows from basic principles of physics and mathematics. Here's why. There are only so many ways particles can be arranged in a finite volume of space. Once you go beyond a certain distance, say 10 to the 10 to the power of 118 meters, the number of possible configurations becomes finite. Huge but finite. Beyond that distance, the laws of probability say the patterns have to start repeating. Like a cosmic wallpaper. It's just like flipping a coin. If you flip it infinitely, you'll eventually get every possible sequence, heads, heads, tails, 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 heads, tails, all of it. Now imagine doing that with atoms, stars, planets, and people. That's what an infinite universe implies. You don't just get one Earth, you get infinite Earths. Max Tegmark, a physicist at MIT, categorized multiverse theories into 4 levels. Level 1 is the least controversial because it doesn't require new laws of physics, only the assumption that space is infinite, and that the laws of nature are the same everywhere. And there's good reason to believe that might be true. The universe, as far as we can see, looks remarkably uniform. The cosmic microwave background, the afterglow of the Big Bang, is nearly identical in every direction. Galaxies cluster in familiar patterns no matter where we look. There's no sign of an edge. No hint that space suddenly stops. In fact, inflation theory, the rapid expansion of space after the Big Bang, almost demands that space be much larger than what we can observe, possibly infinite. So if we accept that, then the level 1 multiverse isn't speculative. It's inevitable. But what does that mean for us? Let's slow down here because the implications are disorienting. If there are infinite copies of you, what does it say about you? If your life, your choices, your memories are just one arrangement out of infinite others, does it cheapen your story? Or does it make it more precious? After all, this version of you, the one here right now, is still you, still conscious, still wondering. The other versions are far beyond your reach. You'll never meet them, never compete with them, never hug them. You only get to live this one, the one you're in. And isn't that the one that matters? There's also something comforting in the idea that the universe is filled with repetition. That somewhere out there, someone just like you got a second chance. That in a distant galaxy, your lost pet is still alive. Your parent never got sick. You said the words you were too afraid to say here. It's not science's job to offer comfort. But sometimes, even the coldest math can warm the soul. And what about the edges? You might wonder, if these other regions exist, can we ever see them? Unfortunately, probably not. They're too far away. Farther than light could ever travel, even at cosmic speed. They're outside our Hubble volume, the limit of what we can ever observe. So while they may exist, they're permanently out of reach. Like a book you know was written, but will never be on your shelf. Still, the idea persists not as a fantasy, but as a consequence. An infinite universe doesn't ask for belief. It just is. And if it is infinite, then you are not alone. Not by a long shot. You are one among uncountable variations, scattered across a tapestry so vast it defies imagination. But here's the twist. None of those other versions of you have your exact thoughts in this exact moment. Only you do. Only this universe has the version of you who clicked on this video, sat in this silence, and felt this breath. and that makes your story, your quiet presence in this infinite sea, no less real. In fact, it might make it sacred. Imagine you are floating in a warm bath. The water is calm, and then suddenly, a bubble forms on the surface, and then another, and another. Each bubble is its own little world, separate, encapsulated, expanding. Now, take that image and stretch it far beyond human scale, beyond stars, beyond galaxies, beyond the entire observable universe. What if our whole cosmos, everything we see, touch, and measure, was just one tiny bubble in an infinite bath of space? This is the strange and powerful idea behind the bubble multiverse, also known as the Level 2 multiverse in physicist Max Tegmark's hierarchy. Unlike the repeating landscapes of the Level 1 multiverse, where physics remains uniform, this next level is a more radical leap. Here, even the laws of nature themselves may be different in each universe. It begins with a mystery we thought we had answered: how our universe began. Back in the 1980s, cosmologists were trying to explain why the universe looks so smooth and flat, even though it exploded into existence from a chaotic fireball. Their answer was a theory called cosmic inflation, the idea that, in the tiniest fraction of a second after the Big Bang, space itself expanded exponentially. Like a balloon being blown up 1 trillion times in an instant, that burst of inflation smoothed out the wrinkles, stretched space flat, and gave rise to the universe we now observe. But then something even stranger emerged from the equations. The idea that inflation doesn't just happen once, keeps happening, continually, endlessly, somewhere. In this view, our universe is not the result of a single Big Bang, but rather one bubble that formed in a much larger, inflating reality, a multiverse of universes. The inflationary process is like a field boiling with energy, and in certain spots, that energy decays, forming a bubble. That bubble becomes a universe like ours. Meanwhile, other regions continue inflating, forming more and more bubbles, each a separate cosmos, sealed off from the others by rapidly expanding space. And here's the truly mind-bending part. Each bubble may obey different laws of physics. The constants we think are universal, the charge of the electron, the strength of gravity, the mass of particles, might be different elsewhere. Some bubbles could have more dimensions of space. Some may never form stars. Some may be dead, cold, chaotic. And some might have their own versions of galaxies, planets, and even life. But they're unreachable, forever. Each bubble is expanding into its own region of space, and the space between them is inflating so rapidly that no light can ever travel from one to another. No message.
No prove. No trace.
Our universe, then, is just one droplet in a foaming ocean. We can never see the other droplets, but we can infer their existence, not through telescopes, but through the logic of mathematics and the behavior of inflation itself. There's something deeply humbling about this vision. For centuries, we assumed that the universe, the one universe, was all there is. And then, slowly, that idea began to unravel. First, Earth lost its place at the center. Then our solar system became one among many. Our galaxy became a speck in a cosmic ocean. And now, even the entire universe we see may be just one among countless others, each with its own laws, its own Big Bang, its own silence. In the bubble multiverse, there is no master design, no privileged structure,
No universal blueprint.
The universe didn't happen once, it happens forever. It's a process, not an event. A wild, creative inflation of possibility, bubbling outward into eternity. To some, this is exhilarating. To others, terrifying. Because it means that our universe, with its perfect balance that allows stars to shine and atoms to form, might not be necessary. It might not be special. It might just be one outcome among billions, randomly realized in the chaotic foam of the multiverse. But maybe that's precisely what makes it sacred, because despite the odds, this is the bubble we landed in. The one where the laws are just right for stars, for chemistry, for life, for breath. Maybe in another bubble, the laws of physics twisted just slightly, and carbon never formed. In another, gravity was too strong, and everything collapsed. In another, the very notion of time unraveled before it ever began. But here, in this one, we are, watching, wondering, existing, even if we're only a brief flicker in one tiny corner of this infinite inflation. It doesn't make our experience meaningless. It makes it precious. We may never know what the other bubbles are like. We may never measure their laws or hear their echoes, but the math that brought us here suggests they're real. Not fantasies, but consequences. And that raises a question science alone can't answer. Why this bubble? Why now? Perhaps there's no reason. Perhaps there is. Perhaps asking is part of being conscious inside this strange pocket of reality. A natural urge in a creature that was born inside a bubble, on a planet, in a galaxy, in a universe that may be just one among an endless sea. So tonight, as you lie back and let your mind wander, remember this: somewhere out there, beyond every star you've ever seen, beyond every galaxy you've ever imagined, the universe is still bubbling. And somewhere, another universe is being born, not with trumpets or fire, but with a silent shimmer of space, stretching open to hold a new reality. Let me know when you're ready to explore the next level, where the rules of quantum mechanics might be writing infinite parallel histories inside every atom. Right here in this bubble. Close your eyes for a moment, and imagine that every choice you've ever made split reality into two. One path where you said yes, another where you said no, one where you stayed, one where you walked away, one where you made the call, one where you didn't. Now imagine this isn't just a metaphor. What if every single possibility you can imagine, every outcome of every decision, every roll of the dice, every quantum interaction, doesn't just exist in theory, but actually plays out in full, vivid reality? Somewhere? Welcome to one of the strangest and most haunting ideas to ever come out of modern physics, the many worlds interpretation of quantum mechanics. A version of reality where the universe doesn't choose one outcome over another. Instead, it embraces all of them, simultaneously, eternally. To understand where this idea comes from, we need to step inside the world of the very small, the realm of quantum mechanics. At this scale, particles behave nothing like marbles or billiard balls. They exist in superpositions, in states where they are both here and there, both spinning up and down, both decayed and undecayed. Only when we observe them, when we measure, do they seem to collapse into one specific state. But what does that even mean? Collapse? Where did the other possibilities go? Why do we see just one outcome? For decades, physicists argued about this. Some believed the wave function, that strange, undulating mathematical object that describes quantum possibilities, collapses upon observation. That somehow, our act of measuring causes the universe to make a choice. But a quiet, radical voice among them, a physicist named Hugh Everett III, proposed something more daring. What if the wave function never collapses? What if every possible outcome of a quantum event actually happens, but each in a separate, non-interacting branch of the universe? When you observe a particle that could go left or right, the universe doesn't decide, it splits. In one universe, the particle goes left. In another, it goes right. And with it, two versions of you emerge. Two observers, each experiencing one outcome, unaware of the other. This is not metaphor, not science fiction. It is a serious interpretation of quantum mechanics, consistent with all our experiments. In fact, some physicists argue it's the simplest explanation.
No mysterious collapse.
No observers influencing reality. Just the wave function evolving, smoothly, deterministically, but branching endlessly. The implications are staggering. Every time you flip a coin, the universe branches. Every time an atom decays or doesn't decay, a new timeline unfolds. Every moment of quantum uncertainty births countless versions of reality, all just as real as the one you know. And in each, a version of you walks forward, living out a life that could have been. In one world, you became a musician. In another, you never left your hometown. In yet another, you're not even born. The cosmic dice rolled differently at the level of particles and atoms, long before your parents ever met. This isn't about alternate dimensions in some faraway cosmic space. This is right here, right now. Branching universes woven into the fabric of our reality. Too close to detect, too delicate to interact, yet infinitely vast in number. It's dizzying, disorienting, but also strangely poetic. Because in this view, nothing is ever truly lost. No possibility is ever wasted. Every path we didn't take still echoes through another version of the world. Every song unwritten, every word unsaid, every door unopened. They all exist, somewhere, fully formed. But don't misunderstand. You're not traveling to these worlds. You're not remembering them in dreams. Each universe is self-contained, with its own internal logic and continuity. The you in another world is not you remembering this one. It is a distinct, parallel version, living a story with the same beginning, but a different middle and perhaps a different end. Some physicists find this idea too extravagant, too ontologically bloated, a multiplication of worlds beyond necessity. And it's true, the many worlds interpretation challenges our intuition. It multiplies existence in a way that feels almost spiritual, mythic. But perhaps that's just our ancient bias for singular stories, for clean timelines and clear outcomes. The quantum world doesn't care for such preferences. It hums with uncertainty, pulses with probability, and, if ever it was right, blooms into universes with every interaction. In this view, reality is not a straight line but a tree, a branching, blossoming, fractal tree of possibility. Every decision a fork, every chance event a bud, and somewhere along its infinite limbs, every version of every person is playing out every life that can be lived. You might wonder, if this is true, then what meaning does this life hold? If every version of me exists, what's the point of this particular path? But perhaps the answer lies not in uniqueness, but in presence. Because this version of you is still the only one you will ever experience. The only one you get to shape, to feel, to live. The others may exist, but they are not here. They are not you, any more than your reflection in a mirror is. They're siblings in possibility, not competitors in meaning. And maybe, in some strange way, this interpretation offers comfort. Because it means no moment is wasted. Every dream pursued or abandoned finds its place. Every silence or scream, every gesture of love or regret, it all matters. Somewhere, always. And yet, we return to the mystery. Because despite its elegance, this multiverse of quantum branches is not something we can observe. We see only our path, only our measurement. The others slip away like morning mist. Inaccessible, invisible, but not necessarily unreal. Like pages in a book you haven't read yet, they're still there, waiting, written. So as you lie in bed tonight, your body warm beneath the covers, your breath slow and steady, consider this. The universe may be whispering through 1,000 versions of you, 1,000 dreams, 1,000 songs. And in this one, this quiet branch of possibility, you chose to listen. You followed a question into the dark and found not just an answer, but an entire forest of realities. And as you drift towards sleep, let that awareness settle gently into your mind. Somewhere the coin landed heads, somewhere it landed tails, and somewhere the universe is still flipping forever. Let me know when you're ready for the next part. The final and perhaps most philosophical vision of the multiverse, one where math itself may be the only reality that ever truly exists. What if the deepest truth of existence is not space, not energy, not even consciousness, but math? Not math as in arithmetic or numbers written on a chalkboard, but math as in the underlying logical structures that define patterns, relationships, and consistency, pure, abstract frameworks that exist whether or not anything physical ever does. Tonight, we step into the strangest, most abstract vision of the multiverse. One that doesn't just stretch the boundaries of physics, but questions what it means for something to exist at all. The idea comes from physicist Max Tegmark, who asked a question both unsettling and strangely liberating. If a mathematical structure is logically self-consistent, if it could, in theory, describe a universe, then why shouldn't it be considered just as real as ours? Not just theoretically real, but actually real. That's the premise of the mathematical universe hypothesis, or, more radically, the mathematical multiverse. In this view, reality is not made of atoms, strings, or quantum fields. It's made of mathematics itself. Our universe is just one solution among infinite possible ones in the grand equation of existence. And if that's true, then every other mathematical structure, every logically coherent set of rules and relations, also exists not in our imagination, but as full-fledged universes in their own right. Some would be wildly alien, with laws of physics utterly unlike ours. Some might lack time altogether, or space, or causality. Some might allow creatures to experience 10 dimensions or none. Some might allow logic loops or backwards time or minds that think without neurons or energy. Some may never produce consciousness at all. And yet they exist. Not in the way that a fictional story exists in a book, waiting to be read, but in the same way our own universe exists. Complete, self-contained, with its own internal logic. Its own beings asking their own version of the question. What is real? Sounds insane at first. Unmoored. But pause for a moment. Why is our universe real? Is it because we can touch it? See it? Measure it? But those are just interactions within the system. If a simulated world inside a computer had inhabitants with simulated senses, they'd experience their world as real too. Reality, in this sense, is not about some external validation, it's about internal consistency. And math is the purest form of internal consistency we know. From this angle, our universe is just one of an infinite family, a particularly hospitable structure where consciousness happens to emerge. And just as life on Earth arises from carbon and chemistry, perhaps consciousness anywhere arises from mathematical symmetry, stability, and complexity, regardless of what space or time mean in that context. In this view, the cosmos is not a physical place, but a mathematical landscape. Every possible structure exists. Every possible universe is real. Ours just happens to be one where minds can evolve and wonder about their place. It's a staggering perspective. Not just because of the sheer scale of what it implies, an infinite number of universes, some beyond all imagination, but because of how simple the core idea is. If math exists independently of us, if it's discovered, not invented, then perhaps its structures exist just as objectively as physical objects. And if reality is simply a mathematical structure unfolding, then all other structures unfold too. This is the ultimate multiverse. Not just many Earths or many versions of you. Not just many laws of physics or many timelines, but every consistent logic system, every thinkable framework, every dream, every contradiction resolved in some internally stable way. It sounds like fantasy, but it is, paradoxically, the cleanest explanation for why anything exists at all. Because if nothing existed, that would be just one structure, the null structure. But if everything that can exist does exist, then nothing is privileged. No set of rules, no constants, no particular beginning gets special treatment. All that can be simply is, and we, floating here in the quiet darkness of our branch of logic, with stars above and memories behind, are just one configuration among uncountable others. But don't be overwhelmed, because in this vision, your experience is not meaningless. Quite the opposite. The fact that you are conscious right now, thinking these thoughts, hearing this voice, wondering about the cosmos, means you are in one of the rare structures where minds can bloom. You are not just a flicker of randomness. You are part of a pattern deep enough, stable enough, beautiful enough for awareness to arise. And in a mathematical multiverse, that makes your world precious. It also humbles us, because it suggests that the laws of our universe, gravity, electromagnetism, quantum mechanics, are not uniquely ordained. They are not the only way things could be. They are just the rules of our particular game, our particular story. Others are out there. Inaccessible, perhaps. Unreachable, always. But real. Some might contain beings with physics we can't comprehend, with senses tuned to dimensions we'll never see. Others may contain no matter, only form. Some might be pure relationships. Some might be empty. Some might be songs. It challenges our idea of what existing even means. Because in this view, there is no creator choosing which universes get to be real. There is no cosmic selection. Reality is the set of all possible realities. And we are just one beautiful line in the infinite poem of mathematics. As you lie here drifting into sleep, think about that. Think about how strange it is that anything exists at all. That there is structure, pattern, experience. That there is you. Not in some absolute singular way, but as a node in the great web of logical possibility. And maybe, just maybe, this soft, starlit universe you find yourself in, with its galaxies and seasons and whispers of love and loss, is the most poetic solution of all. Because here, in this tiny corner of the mathematical multiverse, the equation breathes. And in the silence between your thoughts, you can almost hear it. Let me know when you're ready for the closing chapter, the final reflection that brings all these multiverses together into one question. Why do we find ourselves in this universe, and not another? If you've ever stared at a candle flame and felt that time itself was somehow flickering, trembling between this moment and the next, you've felt the edge of what quantum mechanics tries to explain. It's a theory that doesn't just describe atoms and particles, but the very heartbeat of reality. And at its core lies a mystery so strange, so counter to common sense, that it has baffled scientists, philosophers, and dreamers for over a century. The phenomenon of superposition. Imagine a coin spinning in the air. While it's spinning, it's not just heads or tails, it's both in a way. Now imagine that this isn't a metaphor, but the literal state of a quantum particle. It doesn't just have one outcome, one position, or one identity. It hovers between all possible states simultaneously, a blurry cocktail of realities overlapping at once. That's superposition. And until you observe the particle, until you measure it, it remains in this cloud of possibilities. When you do measure it, the cloud collapses. You get one result. The particle is here, not there. The cat is alive, not dead. The photon goes through one slit, not both. But before that moment of observation, the universe was holding all options open, dancing in a delicate superposition of every possible outcome. This isn't some science fiction idea or philosophical daydream. It's a rigorously tested, experimentally confirmed feature of quantum physics. And it lies at the heart of how electrons orbit atoms, how light behaves, how chemistry works, and even how the sun shines. But it also leaves us with a haunting question. What does it mean for something to exist, if it can be both A and B at the same time? And deeper still, what is an observation? What causes the collapse of the wave function? In the early 20th century, physicists like Niels Bohr and Werner Heisenberg offered one answer. The act of observation is special. It triggers the collapse. When you look, the possibilities resolve. The coin chooses. The particle picks a side. Reality becomes definite, sharp, actual, but only because you looked. Before that, it was nothing more than potential. But this answer, known as the Copenhagen interpretation, leaves us suspended in a kind of metaphysical fog. Why should observation, or the presence of a conscious observer, wield such cosmic power? Why should the universe wait for us to choose a reality? And so another idea emerged, quieter at first, but more radical. It came from Hugh Everett in the 1950s. Instead of assuming the wave function collapses, Everett suggested something shocking. What if it never collapses at all? What if, instead of choosing one outcome when a measurement happens, the universe chooses all of them, and simply splits? In this view, the particle goes left and right. The cat is alive and dead. The coin lands on heads and tails. Each outcome branches off into its own universe. You, the observer, also split, with one version of you seeing one result, and another version seeing the other. And neither ever knows about the other. This is the many worlds interpretation. And while its implications are staggering, it flows directly from the mathematics of quantum theory, without needing special rules or metaphysical observers. In the language of many worlds, superposition isn't just a cloud of uncertain potential. It's a map of branching universes. Every quantum possibility is real, and each unfolds in its own branch of the multiverse. And here's where the quiet awe begins to set in. Because if this is true, then every decision you've ever made or didn't make exists in some version of reality. Every path not taken still plays out somewhere. There's a universe where you moved to a new city, a universe where you kissed them back, a universe where you never stopped writing, or where the illness was caught early, or the words came when you needed them most. All of them, flickering like lanterns in the infinite woods of quantum possibility. And this branching doesn't just happen at big, dramatic moments. It happens constantly, billions of times per second, as particles interact and measurements occur, as photons bounce and atoms jitter. Reality is not a single river but a fractal torrent, a ceaseless blossoming of worlds upon worlds, layered with every quantum event since the birth of the cosmos. So when we speak of superposition, this fragile state of being multiple things at once, we are really speaking of the tremble between worlds. We are touching the veil between versions of reality that coexist, but never meet. In the stillness of a moment, there are echoes of countless others, all equally real, all equally unknowable, and yet we feel grounded. We live in one world. We wake up with one memory of yesterday. We make breakfast in one kitchen, walk through one city. Our experience is singular, even though the quantum reality beneath it may not be. Why? Because we are quantum systems too. Our brains, our thoughts, our bodies, all governed by the same rules. As each version of us diverges with each quantum fork, we become entangled with the outcomes we experience. We don't perceive the branching, we ride the branch we're on. The others are not lost, but forever inaccessible behind the veil of decoherence. And so, you lie in your bed tonight, listening to this voice, in one thread of the infinite fabric. Somewhere else, you paused this recording halfway through. Somewhere else, you never found it. Somewhere else, you're listening again, years from now, remembering this moment with a strange warmth. Quantum superposition is not just a physical phenomenon. It is a metaphor for the human condition. We carry the weight of choices unmade, lives unlived, dreams that could have been. And yet, in some small, poetic sense, maybe they do live on. Not in fantasy, but in the deep quantum architecture of reality itself. And maybe that's what's most humbling of all. That the universe doesn't eliminate possibilities. Keeps them all. Every version of the story is written. Every moment, however fleeting, echoes into an eternity of variations. We are not the center of the cosmos. We are one filament of its branching light. So next time you find yourself caught between options or haunted by what might have been, remember, the coin never really lands. It spins forever. And somewhere, in the quiet breath of the quantum world, you are dancing with all yourselves. Let me know when you're ready to continue with the next part, the final reflection that brings quantum multiverses, inflationary bubbles, and mathematical existence into one final meditation. Why this universe? Why us? Why now? There's something hauntingly beautiful about a road not taken, a path that faded before your feet ever touched it. But what if that path wasn't gone? What if, quietly, without your knowing, it branched away, took form, and continued? What if you simply stepped down one trail, while another version of you took the other? This is not merely poetry. It's the unsettling, elegant idea proposed by a young physicist named Hugh Everett in 1957. Frustrated by the vagueness in how quantum mechanics handled observation, Everett offered a bold alternative. What if the wave function, the mathematical object that contains all possible outcomes of a quantum system, never collapses? What if it just keeps evolving smoothly, deterministically, forever? In this view, reality doesn't choose one result when a measurement happens. It doesn't discard the other possibilities. Instead, the universe itself splits. At each point of quantum uncertainty, every outcome is realized not metaphorically, not figuratively, but literally. Each becomes its own universe, its own branch of reality. And you, your consciousness, your memories, your identity follow just one of them. The others continue too, inhabited by versions of you who saw different results, made different decisions, lived different lives. This is the heart of the many worlds interpretation of quantum mechanics. It suggests a cosmos of unimaginable richness, a branching multiverse where every possible future not only can happen but does happen. Every time a particle's position is uncertain, every time a quantum choice looms, the universe divides. Not into chaos, but into a coherent structure of parallel existences. And it's not just particles that split. We do. Our minds, bodies, fates, all entangled with the quantum outcomes we experience. Everett's idea was radical. It still is. At the time, it was largely ignored or dismissed. The Copenhagen interpretation, which posited that observation causes a wave function to collapse into a single outcome, had already entrenched itself as the dominant philosophy. Everett's vision of a sprawling multiverse felt too vast, too ontologically bloated, too strange. But he was undeterred. He believed that if you simply trusted the math of quantum mechanics, followed it wherever it led, without adding mysterious rules or undefined collapses, you were led, inevitably, to a world of many worlds. It took decades before the physics community began to take his work seriously. Today, the many worlds interpretation is no longer dismissed. It's one of the most widely discussed contenders for what quantum mechanics really means. It doesn't require any extra mechanisms or observers. It's clean, elegant, deterministic, but it comes at a cost. The price is accepting the existence of a near-infinite number of realities, branching every moment, beyond perception, beyond return. What does that mean for us? It means that every choice you've made and every one you haven't exists. Somewhere, in some branch of the multiverse, you took the job. You said yes. You ran away. You stayed. It means that every coin flip, every rolling die, every split-second moment of hesitation carries cosmic weight. Not because it ends possibility, but because it creates it. You are not the sole thread of your story. You are one of countless versions, diverging silently with every breath. And it means that regret, that stubborn ache for what might have been, holds a strange new shape. Because what might have been is, somewhere, you just can't reach it. It's like a ghost of yourself moving in a house next door, always just out of view, always silent behind the walls of decoherence. To Everett, this wasn't fantasy. It was the simplest, most honest reading of the equations. The universe, he said, doesn't need to collapse itself into one version. It's large enough to contain them all. It always was. There's something both liberating and terrifying about this. In one sense, it removes the burden of perfect decision-making. No single choice can ruin everything, because all other choices still live on. Somewhere every path is taken. But it also forces us to reckon with our own meaning in a new way. If there are infinite versions of you, some kinder, some crueler, some luckier, what does this version mean? What anchors your sense of self when you are just one flicker in a sea of selves? Maybe it comes down to attention, to presence, to the branch you are in now and what you choose to do with it. You may not be able to speak to the other versions of you, but you can honor them by living this life deeply, curiously, fully. You are not responsible for what happens in those other worlds, but you are responsible for this one. And that brings us to the deeper philosophical weight of Everett's idea. Because if it's true, if every quantum event spawns a new world, then the multiverse isn't just an abstract space. It's your family. It's your mirror. It's every version of you you've ever dreamed of being, and every version you've feared becoming. There is a universe where your greatest ambitions were realized. There's another where your greatest mistakes were never made. But there's also one where the opposite is true, where tragedy struck, or apathy won, or you never found the courage to begin. These are not fantasies. They are mathematical consequences, if many worlds is correct. They are out there, suspended in the ever-branching quantum tree. But unlike science fiction's versions of the multiverse, where travelers leap between timelines or visit other selves, Everett's multiverse is closed to us. There's no crossing over, no comparing notes. Decoherence, the physical process that isolates each branch, ensures that these realities diverge forever, each locked in its own causality. So why believe in something you can never touch? Because the math leads us here. Because the paradoxes of quantum mechanics, like Schrödinger's cat, both alive and dead, make more sense when you realize the cat isn't in one state or the other, or even both at once. It's in two separate realities. You just happen to be in one. And because it offers a strange kind of peace. Not the peace of certainty, but the peace of acceptance, that the universe is vast enough to hold all versions of the story. That nothing is ever truly erased. That every possibility is, in its own quiet corner of existence, lovingly preserved. Everett died young at just 51, never fully knowing how far his idea would spread. But his vision reshaped the way we think about quantum reality. He didn't just ask what happens when we look at a particle. He asked what kind of universe would allow all outcomes and still make sense. And perhaps on some other branch of the multiverse, he lived longer. Perhaps he watched his idea bloom into the mainstream. Perhaps somewhere he's listening to this right now, hearing his theory whispered into the dark, felt not as a lecture but as a lullaby. The many worlds interpretation doesn't just explain particles. It tells a story, a quiet, cosmic story about choice, consequence, and the infinite dance of possibility. And maybe that's why it endures. Not just because it might be true, but because on some level we already live like it is. Let me know when you're ready to move to the next section, the final reflections, where we ask, if all realities exist, why are we in this one? What makes this version special? Or is it? Somewhere in the deep past, before the stars, before atoms, before even light itself could move freely, the universe did something extraordinary. In less than a blink of time, it expanded, not slowly, not gently, but with a suddenness so absolute, so violent in its precision, that all of space itself was pulled apart faster than the speed of light. This wasn't ordinary growth. This was inflation. Cosmic inflation is one of the most mysterious and foundational ideas in modern cosmology. It proposes that, in the first split second after the Big Bang, the universe didn't just begin. It exploded into being, stretching unimaginably fast, smoothing out the wrinkles in space, ironing the cosmos into something nearly uniform. And yet, as smooth as it became on large scales, the inflationary process wasn't perfectly even. Tiny quantum fluctuations, minuscule, jittery tremors in the vacuum were stretched, too. They seeded the structures we now call galaxies, stars, and planets. But inflation, by its very nature, never truly ends everywhere. It is believed to be eternal, in some places slowing and stopping, creating bubble-like regions that cool into what we see as our universe. In others, it continues unchecked, space still birthing new regions, new pockets, new beginnings. Each one of these pockets is a universe in its own right, vast, causally disconnected from the rest. These are not science fiction wormholes or alternate timelines in the Hollywood sense. These are real, physical regions, separated not by time or fantasy, but by the relentless stretching of space itself. You can picture it like a boiling pot, each bubble that rises and pops on the surface representing a separate universe, while the boiling medium continues to churn, inflating forever. In this framework, our universe is but one bubble in an infinite cosmic froth, a universe among universes. We are a local lull in a greater storm. The idea is as unsettling as it is profound. It means the Big Bang wasn't the beginning of everything. It was the beginning of our region. Other regions, other universes may have banged too, or differently, or not at all. Their physics may vary. Their laws may curve in different directions. Constants we take for granted, like the strength of gravity or the speed of light, may be mere regional customs in this broader cosmic empire. And yet we cannot see them, not because they're theoretical, but because the fabric of space that separates them from us is expanding faster than light can bridge. Even if we sent a signal, it would never arrive. Even if their stars exploded, their light would never reach us. They are not behind a wall, but beyond it, behind a moving horizon we can never catch. This version of the multiverse, the inflationary multiverse, isn't about quantum possibility or mathematical abstraction. It's about real estate. It's about the way space itself behaves, and the strange way it multiplies. It's grounded not in fantasy, but in physics, driven by a scalar field, a hypothetical energy that once dominated the early universe, pushing space outward with repulsive force. And as strange as it sounds, this idea wasn't invented to explain the multiverse. It was created to fix the early universe. Its flatness, its smoothness, its symmetry. Inflation explained all that elegantly. The multiverse came as a consequence, a side effect, a natural extension of a theory that works too well. Of course, it raises questions. What determines which bubble gets which laws? What makes our universe the way it is? Are there infinite bubbles with every possible configuration? Or is there some deeper pattern? A rulebook hidden inside the inflationary engine? We don't know. But the possibility that each universe could be its own sealed environment, that inflation might be eternally generating realities beyond reach, is both thrilling and humbling. It also brings a strange new meaning to cosmic loneliness. Not just because we are small, not just because we are fragile, but because, even at our most advanced, we may never know what lies beyond our own patch of space. No telescope can pierce the inflationary veil. No ship can sail across the sea. We are, in a sense, cosmological castaways, isolated by the very process that gave us birth. And yet, within that isolation, there's a quiet kind of miracle. Because our universe did cool. It did stop inflating. It did give rise to matter, chemistry, biology, thought. Somehow, in this one bubble among countless others, conditions allowed complexity to form. Stars to ignite, planets to coalesce, minds to ask questions about their origins. We may not know why this bubble formed the way it did or how rare that is, but we are here and we are watching the horizon, and we are wondering. Inflation doesn't answer all the questions. In fact, it creates many new ones. But it paints a picture of the cosmos that is far richer, more dynamic, and more alive than the traditional view. Instead of a single bang, a single space, a single time, it gives us a universe that is growing eternally, unfolding new domains forever. It suggests that creation is not an event, but a process. Not a moment, but a momentum. And if that's true, then the multiverse isn't elsewhere. It's everywhere. Not just in science papers or blackboard equations, but in the very logic of how space unfolds. The same process that smoothed the sky also seeded the seeds of separation. The same expansion that brought us light also cast shadows we can never chase. Somewhere out there, in a region we will never reach, another bubble forms. It cools. It grows. Perhaps it remains stillborn. Perhaps it flowers with suns and creatures and thoughts that echo our own. We cannot know. But if cosmic inflation is real, then we are not alone in existence, only in experience. So tonight, as you look up at the stars, remember, this sky, this stretch of space, this bubble of being, it may not be all there is. It may be just one whisper in a choir that sings beyond time, a single note in an endless cosmic symphony, not less precious for it, but more. Let me know when you're ready for the final part, the closing reflections. So if there are infinite universes, why this one? Why are we here? Somewhere deep in the fabric of everything, beneath atoms, beneath space and time as we know them, something else might be moving. Not particles, not waves, but vibrating strings. This is the strange promise of string theory, that the fundamental building blocks of our universe are not dots or points, but tiny loops of energy, each vibrating in its own distinct rhythm, giving rise to everything, from gravity to light to the very idea of space itself. But string theory doesn't stop there. To work, to be consistent, it demands more than just the 3 dimensions we walk through, and more than the 4th we move through with time. It needs more. 6 extra spatial dimensions, maybe 7, maybe more. Tiny, curled-up dimensions, hidden from us not because they're far away, but because they're so small, folded into themselves like a sheet crumpled so tightly it becomes invisible to the eye. We don't move through these dimensions because we're too large, too slow, too bound by our familiar physics to even notice them. Still, they may be real. And in some versions of string theory, those extra dimensions don't just sit passively beneath reality, they shape it. In fact, they determine the kinds of particles that can exist, the strengths of the fundamental forces, the very structure of what we call laws of nature. What we take to be universal might only be local, a property of how our own corner of the higher dimensional space is folded. Now imagine that in this grander space, a space with more dimensions than we can perceive, our entire universe is like a three-dimensional sheet. A membrane, a brain as physicists call it, floating, expanding, rippling ever so slightly, and perhaps we're not the only one. Other brains may exist, parallel to ours, separated not by light years, but by fractions of a millimeter in dimensions we cannot sense. They might be drifting quietly near us, like ghost ships in a fog, unseen but potentially just a breath away. This isn't a poetic metaphor. In certain formulations of string theory, particularly M-theory, its more comprehensive cousin, such brains are predicted naturally. Our universe could be embedded in a higher dimensional bulk, where multiple brains exist side by side. Each one might hold its own universe, its own matter, its own laws. We might be just one of countless sheets, fluttering in a space we don't know how to touch. And sometimes these brains might collide. The idea is haunting, that the Big Bang might not have been the beginning of everything, but rather the moment when our brain struck another. The energy released in that collision, cataclysmic and unimaginable, could have created all the matter and radiation we now see. In this picture, the universe didn't start from a singularity, but from a contact, a cosmic crash between parallel worlds. And perhaps one day it might happen again. But even without a collision, the existence of nearby brains suggests a quiet, steady kind of multiverse, not one born from inflation or quantum randomness, but from pure geometry. From the way higher dimensional space folds and floats. These parallel brains might be unreachable. No force or particle may bridge the gap between them. Or perhaps gravity, the most elusive of forces, does. Some scientists suspect that gravity might be leaking into the higher dimensions, explaining why it's so weak compared to everything else. So, then its faint whispers might carry clues about other brains, parallel universes drifting silently beside our own. It's a dizzying thought, that right now, just beyond the veil of perception, another universe might be unfolding. Maybe it's cold and lifeless. Maybe it's teeming with structures that mirror our own. Maybe its stars shine a little brighter. Maybe its physics are just different enough that life, as we know it, could never arise. We have no way to see. No telescope can point sideways into a curled-up dimension. No particle accelerator can open a doorway to a neighboring brain. And yet, the math doesn't flinch. It whispers that we might not be alone, not in some far-off galaxy, but in the very same place, separated by a dimension we cannot traverse. The elegance of string theory lies not just in its complexity, but in its ambition. It doesn't try to explain part of the universe, it tries to explain all of it. All forces, all particles, all constants. And as a side effect, it gives us a multiverse, not of choice or chance, but of form. A multiverse sculpted by geometry and hidden dimensions, where our universe is one possible configuration among many, each folded into a different pattern, vibrating with a different song. And if this is true, if we are truly living on a floating brain, then the universe is far stranger than even the boldest stories have imagined. It's not a space filled with things. It is a thing, filled with spaces, each one a theater for its own unfolding drama, each one invisible to the rest, except perhaps through the quiet pull of gravity, or the distant echo of a collision written into the background radiation of our sky. So here we are, living our lives on a sheet of space, tracing paths through 3 dimensions, with time flowing forward like a soft river, never suspecting that just beside us, closer than the air, yet forever out of reach, another brain may be drifting, carrying its own story, its own physics, its own version of the word reality. And maybe, just maybe, on some night not unlike this one, someone or something on that parallel sheet might be wondering, too. Somewhere out there, or maybe right here, in some direction we cannot point to, there may be another version of you. Not just someone who looks like you or sounds like you, but someone who is you in every way, except for a single turn in the road. A choice made differently, a moment missed or taken, a life unfolded not according to this path, but another. Maybe it happened when you chose a different college, or stayed with someone longer, or left sooner, or answered that call, or didn't. In the strange, sprawling possibility of a multiverse, that version of you could be living a life so familiar it would ache to look at, just a few degrees off from this one. A life where you wake up to the same sun, but next to someone else. Where your morning coffee tastes the same, but the job you're heading to is not one you've ever known. Maybe you're happier there. Maybe not. Maybe the pain you carry in this world never found you in that one. Or maybe you carry a different kind of pain, just as sharp, but shaped by different events. Quantum mechanics, in its most unsettling interpretation, the many worlds interpretation, suggests that reality doesn't collapse into one outcome. It branches. Every time there's a quantum event, reality splits. And we, riding the wave of what we call the present, simply follow one of those branches, unaware of the others we've left behind. But if all the branches are real, then somewhere else, you are the one who said yes instead of no. You took the leap, or you played it safe. You stayed. You ran. You forgave. You didn't. This idea isn't just poetic, though it is undeniably poetic. It's rooted in physics. It flows out of equations that physicists take seriously, even if the emotional consequences often go unspoken. It tells us that the universe isn't choosing outcomes. It's letting them all happen, and we are just one strand of experience, threading through a vast and tangled fabric of everything that could be. So what does that mean for you? The one sitting here now, breathing softly into the dark, wondering about your place in this endless cascade of realities? It means, perhaps, that your regrets aren't as final as they feel. That somewhere, another you made the choice you couldn't. Lived the life you couldn't bear to try. Maybe they're thriving. Maybe they made mistakes of their own. But they're out there, tracing the outlines of a life that was always within reach, yet never quite yours. You are not just the sum of what you did. You're also the ghost of what you almost did. The echo of 1,000 lives unlived. It also means you're never really alone, not in the way you might think. The isolation that sometimes wraps itself around your chest like cold wind. Maybe it's not as absolute as it feels. Somewhere, another version of you might be sitting with someone you lost. Might still be in the middle of a story that ended here. Might still have a chance to say what you didn't say. There's no way to reach across and swap places. But still, the knowledge changes something. Just the idea that those versions of you exist can soften the finality of your choices. Not to excuse them, but to understand them, to hold them more gently. But it cuts both ways, doesn't it? Because if another you is living your dream, then it follows that you, too, might be someone else's ghost. Someone else's what if. In another universe, a version of you is watching their life come apart, wondering what would have happened if they had done what you're doing now. Taken the risk you took or found the courage you still haven't. To them, your life is a miracle, a path they missed, a version they ache for. The strange, the kind of comfort that brings. Not hope exactly, a sense that your story isn't small or isolated, but part of an unimaginably large chorus, singing variations on the same song. A song of choices and chances, of loves found and lost, of versions of us that almost were, and versions that still might be. And what if, for just a moment, you could see across those versions? You might be overwhelmed by all the joy you never had, all the heartbreak you avoided, all the lives you didn't live. Or maybe you just feel awe, not regret, not envy, just awe at how delicate and vast your existence really is. That you are one thread in a tapestry so intricate no mind could hold it. A thread that matters not because it's the only one, but because it's yours. And you're here. You get to be this you. With all the weight and wonder that comes with that. There's something profoundly humbling about the idea that we are not the only version of ourselves. Can make the ego tremble, to realize how arbitrary some of our triumphs and tragedies may be. But it can also make the soul exhale. Because it reminds us that perfection was never the point. That we are not here to live the only good life or the only right life. We are here to live a life. One version. One unfolding. One song out of the infinite possible songs. And maybe, just maybe, knowing that frees us to live more fully. Not to fear every mistake. Not to mourn every mischance forever. but to step forward gently, with the knowledge that this life, this one right here, is a miracle of possibility. That you, right now, are the universe made personal. A version that breathes. A version that feels. A version that gets to wonder about all the others. And perhaps that's the real gift of the multiverse. Not just the science. Not just the speculation. But the softness it brings. The way it allows us to imagine our lives not as rigid paths, but as stories in motion. Stories with echoes. Stories with neighbors. Stories that, in another world, turned out just a little differently. And yet, this version of you is still here. Still moving forward. Still unfinished. So what will you do with that? For most of human history, we believed we were at the center of it all. First, it was Earth, the stage upon which all life danced, fixed and favored by the cosmos. Then it was the sun, and we moved outward in reluctant awe, reshaping our understanding, each time more humbled than before. Slowly, science peeled back the curtain and showed us that the stars are not lanterns hung for us, that galaxies do not spin for our drama, and that we, while precious, are not privileged. But even as we accepted that Earth was not the center, we clung to another idea just as quietly comforting. That the universe, our universe, was the whole of it. That the rules we've discovered here, the constants we've calculated, the forces we've named, gravity, electromagnetism, the nuclear interactions, are the rules, the fundamental bedrock of reality itself, eternal and universal. But what if they're not? What if the laws of physics are not universal after all, but local? What if they are simply the regional dialect of our particular cosmic neighborhood? No more absolute than the color of the sky at dusk? In some multiverse theories, this is not just a possibility, it's a necessity. In the grander vision of reality, there may be countless other universes, each sealed away from the next, not merely separated in space but fundamentally distinct in how they work. Their gravity may behave differently. Their particles may not combine in ways we understand. Their constants may be utterly alien. Their dimensions may be curled in ways our minds cannot grasp. In such a picture, our universe is not the standard template. It's not the reference point. It's just one bubble of physics among an endless froth. Our energy, these are not truths etched in the bones of reality. They are features of our own peculiar cosmic bubble. And here's the thing that stirs both awe and unease. If the laws of physics can vary across universes, then the structure we see around us, the stars, the galaxies, the delicate chemistry of life, might not be inevitable. It might be a cosmic accident, a rare arrangement in a vast ensemble of failed or lifeless realities. Perhaps in most universes, matter doesn't clump, or atoms don't form, or time itself doesn't flow in a way that could sustain experience. And yet, we find ourselves in one of the few places where everything works out just right. Not because we're special, but because we have to be here. Because only in a universe with these conditions could we even be asking the question. This idea, called the anthropic principle, isn't about arrogance. It's about selection. Out of the countless universes that might exist, we are observers in one that permits observation. And that alone tells us nothing about how common our laws are. It only tells us they exist here, and that's why we're here to witness them. But doesn't that feel strangely destabilizing? That the speed of light, the strength of gravity, the charge of the electron, all the quantities we measure with exquisite precision, might be nothing more than local settings like a slider adjusted differently in other realms? That what we call laws might be more like regional customs. It shifts something deep, because we often assume that if we know the laws of physics, we know something eternal. That we are glimpsing the mind of nature itself. But maybe we're only reading one chapter in a book that stretches far beyond our reach, and each chapter written in a different language. If this is true, then what we think of as the universe becomes less like a singular object and more like a patchwork. A quilt sewn from endless fragments of reality, stitched together not by proximity or similarity, but by the fact that they all exist. Each universe, a story with its own grammar, each one operating by its own internal logic, perhaps inaccessible to any other. In this vision, our place is not central, not final, and not fully comprehensible. And yet, There's something freeing about that. It releases us from the illusion of supremacy. It reminds us that existence is not built around us. It simply includes us. We are not the axis of reality. We are a ripple in its vast, unpredictable fabric. And maybe, just maybe, that makes our world more precious, not less. Because it's not guaranteed. It's not inevitable. It's not even particularly likely. If the multiverse is real, the balance that allows stars to form, that allows carbon to bond, that allows consciousness to flicker into being, that balance is delicate. It is not the rule. It is the beautiful exception. And we are living it. This understanding humbles the heart and sharpens the eye. It reminds us that curiosity is not just a luxury. It's a responsibility. That awe is not weakness, it's wisdom. That to look up at the stars and wonder is not the act of a naive child, but of a mind brave enough to face the immensity without flinching. So here we are, in this small, brief universe with its peculiar rules. A universe where life can think, and thinking can question, and questioning can open doors to infinite other possibilities. A universe where the laws make sense to us, but only because we are their children. A universe that may be just one bubble among uncountable others, each singing its own version of reality into being. And as we listen, we begin to realize, the cosmos is not built to comfort us. It is not built for us at all. But somehow we are here, aware of it, wondering what it means. And maybe, in the end, that's enough. If the multiverse is real, if every decision branches into a new universe, where each possible outcome lives on somewhere, then what does it mean to choose? It's a question that goes straight to the heart of human experience. We make choices every day, some small and forgettable, others that seem to shift the entire arc of our lives. We struggle with regrets, we weigh consequences, we wonder what might have happened if. But if all those ifs exist somewhere, if there's a version of you who said yes instead of no, who turned left instead of right, then was there ever truly a choice to begin with? In the many worlds interpretation of quantum mechanics, every outcome that could happen does happen, somewhere. Not metaphorically, not in imagination, but literally. An entire universe splits off, branching into reality with each quantum decision, no matter how small. In that view, there isn't one you. There are countless versions of you, diverging with every possibility. One chooses love. One walks away. One forgives. One does not. This idea is dazzling, but also deeply unsettling. Because if all outcomes occur, then every decision you could make is already being made. Somewhere. By another you. Right now. Does that make your current experience less real? Less meaningful? If you're shaping the path ahead, it gives us a sense of control, of authorship. But if every option is enacted somewhere, if every story is told, then you're not choosing which story happens. You're only becoming aware of which version you're currently inside. And that introduces a strange tension. On one hand, you feel like you're choosing because from the inside, this version of you doesn't experience the others. You don't remember your alternate self who took the job or walked away or never made that call. In this life, you did make a choice, and it matters because it shaped everything that followed. But on the other hand, there's the growing awareness that this moment, this decision, is not singular. It's part of a vast branching pattern, one among uncountable forks in a cosmic tree. So where does that leave free will? Perhaps it's a matter of perspective. From the outside, from the God's eye view of the multiverse, you might not be choosing which reality exists because they all exist. But from the inside, from the view of a conscious being moving through one path, you are absolutely choosing. Because while all versions may be real, this version is the only one you can live. You are experiencing this thread of existence, and that experience is shaped by your awareness, your values, your actions. In this light, free will isn't about choosing whether a world exists, but about choosing how you move through the one you're in. Even if there's a version of you who gave up, it's not this you. Even if another version betrayed their principles, you haven't. That distinction matters not because the other versions don't exist, but because they don't define you. Only this path, this set of choices, this unfolding story, that's your life. But still, the question lingers. If all outcomes occur, Is there really such a thing as accountability? If you're always both the hero and the villain in different threads, does it matter what you do in this one? And yet, we don't live in all threads. We live in this one. And that matters. When you reach out with kindness, when you choose courage over fear, when you hold on to honesty even when no one would know otherwise, those moments are not erased by the existence of their opposites. They are made meaningful because you still chose them, knowing you could have done otherwise. You made a mark on your reality, and that is no small thing. The presence of other paths doesn't cheapen this one. If anything, it elevates it. Because among infinite possibilities, this is the one you're living. That makes your attention sacred, your awareness rare, your experience, though statistically insignificant on a cosmic scale, utterly irreplaceable. Some say that if fate is real, freedom must be an illusion. But maybe that's a false contrast. Maybe fate is the landscape, the whole terrain of all that could be, and free will is the path you walk through it. Both can coexist. The landscape doesn't force you to take any particular trail. It simply offers them all. The choice is still yours. Even if every route is walked by someone, only you are walking this one. And yes, there is something haunting in knowing that a version of you always makes the wrong decision. That somewhere you fail. You break a heart. You give up too soon. But maybe that knowledge isn't a curse. It's a mirror. It reminds you that the stakes are real, that your actions echo, even if only in one tiny corner of the multiverse. And there's beauty in that, too. Because if there are infinite versions of you, it means that the potential for growth, for redemption, for bravery, exists eternally. Somewhere you always find the strength. Somewhere you always make the better choice. And here, now, you have the power to become that version, not by rejecting all the others, but by embracing your agency in this moment. So perhaps the question is not whether you have free will, but whether you honor it. Whether you show up to your own life with intention, with presence, with care. Because no other version of you can live this day. No other timeline contains the exact blend of circumstances, challenges, and connections that you face. This moment is yours alone. In a sea of branching paths, it is the one shore where your feet now stand. And that is where freedom lives, not in the illusion that you control the entire map, but in the deep truth that you can choose how to take your next step. So take it, not because you're the only one who ever could, but because you're the only one here to do it. There's something deeply human about the idea of other worlds. Perhaps it's because we've always dreamed of them, whether we called them heavens, parallel dimensions, or simply the life we might have lived had things gone differently. The idea of somewhere else has always lingered in our imagination. But now, physics lends this yearning a strange kind of scientific legitimacy. The multiverse, once confined to myth or metaphor, might just be real. And that brings with it a question that feels more emotional than logical. Is the idea of a multiverse a source of comfort or sorrow? It depends on how you look at it. There's comfort, perhaps, in believing that somewhere out there, a version of you didn't lose that person. They held on, said the right thing at the right time, and the relationship endured. There's a version of you who took the leap you were too afraid to make, or who never made the mistake that still haunts you. That life, the one you sometimes see behind closed eyes when the room is dark and quiet, might be playing out in full elsewhere. You didn't miss it. Still exists. Just not here. That can be soothing in a way. We tell ourselves we did the best we could with the information we had, with the emotions we carried, with the pain we hadn't yet learned how to name. And now we can imagine that somewhere, in another universe, we did better. Or differently. And maybe, just maybe, things turned out the way we secretly wish they had. But there's also sorrow in that vision. The strange, hollow ache. Because if those other lives really do exist, we're shut out from them forever. You can't cross over to meet the self who never grew apart from your parents, or who never lost their health, or who chased a passion instead of settling into safety. You can only imagine them, knowing they're close in concept yet unreachable in reality. Like stars you can see but never touch. And what does it mean, really, to know there's a happier version of you somewhere? If you're trapped in a thread that feels dim and fraying, for some it might feel like insult added to injury. A reminder that not only did you lose something precious, but the loss wasn't necessary. That the joy was always one choice away, one different moment, one impossible rewind. But now it's not yours. This tension between comfort and grief is the emotional core of the multiverse. It's not just about physics or philosophy. It's about regret. It's about longing. It's about all the doors we closed and wonder what lay behind them. In a single universe world, those doors are simply gone. But in a multiverse, they're still open somewhere. Which is more merciful? Which is more cruel? Maybe it depends on what kind of heart you have. For the hopeful, the multiverse is a kind of bomb. Says no story is truly lost. No love is truly extinguished. Somewhere, the version of you that needed to speak spoke. The version that needed to listen listened. The version that had to be brave found the courage. And maybe knowing that makes it easier to forgive yourself for the things you didn't do. But for others, the multiverse only sharpens the edges of regret, because it implies that every missed chance lives on like a ghost. It never really dies. It just moves to a new address. And sometimes, that thought can haunt you more than the loss itself. You're not just mourning what didn't happen. You're mourning its eternal life, somewhere just out of reach. And yet, maybe the real question isn't whether the multiverse brings comfort or sadness. Maybe it's how you choose to relate to the idea. Because even if all those alternate realities exist, you still only get to live this one. You still only get these people, these moments, this fleeting thread of time that you call a life. And perhaps it's that very limitation that gives it weight. We think that abundance makes something meaningful, but often it's scarcity that does. A flower is beautiful not because there are infinite flowers, but because it blooms once and then fades. A moment is sacred because you can't go back to it. A life is precious because it ends. So if the multiverse is real, if there truly are infinite versions of you, it doesn't lessen the value of this version. It magnifies it, because among all the versions, this is the one you know. This is the one that breathes through your body, feels through your skin, hopes through your voice. This is the only you that you'll ever be conscious of. And maybe that's the point. Not to pine for other lives, but to honor this one. To see it as rare, not in its uniqueness, but in your awareness of it. You are here. You are awake. That alone is enough to make this moment sacred. Still, it's okay to feel both things at once. To let the idea of the multiverse hold both comfort and sorrow in the same breath. To be warmed by the idea that somewhere, a better ending exists. And also to grieve that it's not this one. That complexity, feeling joy and ache together, is the mark of being human. Of knowing there are infinite possibilities. And still having to live just one. And maybe, in the end, that's the real gift of the multiverse. Not a promise that things could have been better, but a gentle nudge that you still have time. That even in this singular thread of reality, there's room to change, to forgive, to try again. That not all the doors are closed. That you can still become the version of yourself who did the thing. Who said the words. Who came back to life. Because even if another universe holds a happier ending, this one still holds your hands. This one still has a future waiting to be shaped. And you are still here to shape it. So here we are again. After all the spirals of thought, the strange theories, the dizzying expansion of what might be, we return to something far simpler ourselves. You, sitting wherever you are, listening in the stillness of your room, or maybe beneath a sky freckled with stars. You breathing, you wondering, you are small. In every measurable way, you are smaller than a grain of sand in a desert 1,000 times larger than anything you can see. Your lifetime a flicker. Your body stardust held together by fragile chemistry. In the grand story of the cosmos, you barely take up a footnote. And yet, you feel. You ask questions. You imagine other worlds. And there is something miraculous in that. Out of all the infinite possibilities, all the parallel timelines, all the universes we may never see or touch, this is the one that holds you now. This is the one where your heart beats, where your memories form, where your footsteps leave quiet prints on the earth. This is the one where the wind brushes your skin, where music makes you cry, where someone, somewhere, once looked into your eyes and smiled. Maybe that's enough. You don't have to know how many universes there are to appreciate this one. You don't have to understand quantum mechanics to taste rain. You don't need proof of parallel lives to feel the sacred weight of your own. Maybe meaning isn't something waiting to be discovered out there. Maybe it's made moment by moment, by how you choose to live right here. Can you feel it? That quiet pull inside you, gentle, steady. Not the hunger to know everything, but the invitation to be present in anything. Not the rush to escape this world for another, but the reverence to stay. To really stay. Because while it's true that the universe might be infinite, your time in this version of it is not. This life, this body, these eyes that see the light of day will one day be gone. Just like stars burn out, just like galaxies drift. But now, right now, you are here. So look up. Let your mind wander. Let it imagine all the strange worlds beyond your reach. Picture them layered like reflections in an endless mirror. Millions of versions of you, standing beneath millions of skies, thinking maybe the same thought at the same time. A constellation of selves, all spinning quietly through the dark. But then, come back. Come back to this breath, this sky, this pair of hands, this version of you, the one who was chosen by chance or mystery to live this story. And maybe that's all the miracle you need. We chase these questions: what is reality, what lies beyond? Is this all there is, not because the answers will always come, but because the questions themselves mean we are awake. To wonder is to be alive. To long for something greater is not weakness. It's the echo of the stars in your blood. It's the gravity of meaning pulling you home. Maybe one day we'll know more. Maybe one day we'll step through the veil, measure the unmeasurable, touch the edge of a multiverse. Or maybe we won't. Maybe we never can. But even if we can't, even if we live our whole lives never knowing how many worlds exist, never seeing beyond the veil, we still get to live this one. And maybe, just maybe, that's enough. So let this moment be quiet. Let it be sacred. No answers, no urgency, no need to prove anything. Just a person. Just the sky. Just the quiet hum of existence. Like a lullaby from the stars. And one last question. If you could step into another universe, one where your regrets were erased, your choices rewritten, your life entirely different, would you go? Or would you stay here and live this world, this life, as deeply as you can? Sleep well, traveler of thought. The universe is vast, but you are already a miracle.